What's up, YouTube? It's that time of year again where everybody's pulling out their pre-lit Christmas trees. Sure enough, this year I pulled out mine and put it together and quickly noticed that a strand of about 50 light bulbs was out on my pre-lit Christmas tree. So today I'm going to talk to you a little bit about what I did to go and debug that, and it's a little bit different from the traditional methods that you might see in some other YouTube videos. So the first thing I want to talk through is this diagram here, which shows you the basic circuit for these pre-lit Christmas trees. And basically how this works is you have your power plug that comes into the wall, and this red line is basically supposed to represent the hot line. And there are multiple strands of about 50 bulbs that run throughout the Christmas tree. So if each of these red dots represents a light bulb, electricity will flow through those. This is a diagram showing about 8 bulbs per strand, but the reality is there's about 50 in series per strand on the tree, and then there are multiple of these strands that make up the pre-lit Christmas tree. Now, typically what you will see on a tree is, every once in a while a light bulb will actually not be lit up, it'll be burnt out. And in those cases, these bulbs are actually designed in a way that they can still conduct electricity even if the bulb is burned out. So just because you have a burned out bulb doesn't actually break the circuit, but if you do have a strand of 50 bulbs that are out, or a full strand that are out, that means that you do have some sort of mechanical break. So it could be a different problem with the bulb, not just that the filament burned out, but that there's a mechanical break somewhere in the bulb, or you have a mechanical break elsewhere in the chain. So what I'm going to talk through is what I did to debug the circuit. And one of the challenging things with the pre-lit Christmas tree is that the actual wiring doesn't quite look this nice and neat. The return wire is actually interwoven into the power line. It's woven throughout, where all the lights go, which make it really hard to debug a strand of 50 bulbs with the traditional method. And the traditional method that you'll see on other YouTube videos is, somebody will use this voltage detector circuit and basically go bulb by bulb to try to debug where the mechanical problem might be. And I found this to be really challenging on the pre-lit Christmas tree because it was picking up signals from elsewhere, and it wasn't the traditional line of bulbs that was just straight and easy to separate the return line from the power line. So what I ended up doing was, with my strand of 50 that was out, I actually started with a full 50 bulb replacement around the entire strand of 50. So I had to pluck the actual bulb and casing out of all 50 sockets. I just followed the wire, and then I bought a fresh set of 50 bulbs off of Amazon and replugged them in. And even after replugging in all 50 of them, I still did not get the circuit to work. So that resulted in sort of a next step of debug to figure out what the problem was. So for the next part of the debug, we got to talk a little bit about how these bulbs actually mechanically connect together. And what I've done here is I've taken an example of 3 bulbs that are connected in series and put together a diagram of how these actually mechanically and electrically connect to each other. So what you see here outlined in blue is actually the casing, the socket for the bulbs to plug into. And what you see here is the casing of the bulb and some of the wires that run through it. And so each bulb is simply comprised of the actual bulb, the casing, and then 2 wires that go in different directions. And you can see here in this third diagram an example of where if you push the bulb down into the socket, there's a mechanical connection that actually takes place between the wires and this piece of metal in the bulb. So after the 50 bulb replacement did not work, what I needed to do is I needed to work my way through this strand of light bulbs to determine where I was actually losing power, meaning power was coming in on one side of the bulb and then it was not leaving the other side of the bulb. And in order to do that, I used basically a multimeter, which you can see here. You can buy these off of Amazon. They're about $10 to $12 for just a basic one. This multimeter allows you to do voltage detection, but what makes it a little bit different from this type of voltage detector is that I could actually use this prong to reach into these sockets and actually touch the metal components and get a very clear reading of where I was seeing voltage and where I was not seeing voltage. So I basically just reset this to AC voltage and was able to, even just with the single red one, I didn't necessarily have to plug the black into anything in particular, but I was able to reach into the socket and get, in a known good case, voltage reading on one side and not a voltage reading on the other. So in order to do the actual voltage detection, I started at the end of the strand that was connected to the return line and worked my way backwards. And I would unplug the light bulb that I was looking to do the detection on so I could actually reach into the socket and just touch the tip of this metal component up to the metal component of the strand. And what I was looking for was an instance where I have voltage on one side but not on the other, because then I know that that particular socket is getting power into it, but it's not having power leave it. As I was making my way through the different sockets, I was getting a 0 voltage reading on both sides. So I'd proceed through the strand about every 8 bulbs or so, trying to find an instance where I was receiving voltage on one side, but not voltage on the other side. It turns out that I was not receiving voltage throughout the strand all the way to the beginning bulb. So I knew that this was actually the mechanical break in my circuit. It happened from the hotline coming in. And what ended up happening for me was I took a deeper look into that particular socket and noticed that the mechanical metal component where the bulb would actually connect in was actually bent back. So it kind of looked like this. It was kind of bent away pretty drastically. And it's sort of a uniqueness of this connection bulb right there. These sockets are just a little bit different with how they're mechanically built. And so because the metal component had actually been bent back, when the bulb was plugged in at that location, there was actually no conduction happening. So I was able to pinpoint specifically which socket in the string of 50 had the mechanical problem. This was actually as simple as just putting a screwdriver into the plastic component and actually just pushing that metal connection out a little bit so that when the bulb comes in, it was getting a good connection. And that ended up resolving the issue. So all 50 bulbs lit up no problem. And so the net takeaway is sometimes these sorts of tools aren't super useful when you're working with a pre-lit tree where the wires are really wrapped around each other, and this might be picking up different signals from different parts of the circuit. And the other thing is using this multimeter to actually get a good read, a good mechanical connection on those bulbs so you can truly understand where you're losing voltage in the circuit. So now I'll move over to an actual Christmas tree and show you what this debug actually looks like with the Christmas tree. So here we have a zoomed in example of what happens when you make that mechanical break in the Christmas tree. So this is a bulb here that is plugged in. As you can see, all the bulbs here on the lower branches are lit up. And if I unplug this bulb, you will notice a series of lights turn off. So if I kind of pan the camera around here, all these bulbs are actually not lit up. And if I plug in that same bulb that I just unplugged, you will see them light up. So this is what it looks like when the whole strand of 50 bulbs actually goes down. Now I'll show you how I use the multimeter to do the actual voltage detection. So again, this is my multimeter, and just turning it on to the voltage setting, I press select so that it's measuring AC voltage. So here I'll show an example of how I go about probing within the socket to look at the voltage. And one thing about the multimeter is you're not necessarily going to get an exact 0 voltage reading, but what we are looking for is that large difference in voltage reading where again we're getting clearly voltage on one side and low voltage on the other, indicating that we're getting power to the socket. And so if we stick in a bulb, that electricity should conduct. So here again, I just have the multimeter with the red tip. This is the socket that does not have the light bulb in it, and you can see that there's other light bulbs that are out throughout the tree. So I'm gonna go ahead and plug the prong in and touch just one side, so we're getting an AC voltage reading about 1.3 volts. But if I touch the other side, we're getting about 8.87 volts. So you can tell that there's a pretty big voltage differential in this socket, which means we're getting power coming in on one side and not very much power leaving the other. That's a good indication that if we plug in the bulb that is mechanically working, we will get the tree to light up. So now I'll show you what it looks like when we have that break in the circuit down the line, very similar to the example that I showed on the whiteboard. I'm gonna reach back into the tree and show you what one of those light bulb sockets looks like that is at the beginning or the end of a chain. You can see here it's a little bit of a different socket setting. And what I'll do is I'll remove this bulb from the chain. So now we know that we have a mechanical break at the beginning of the chain, and I'm gonna take a fresh reading of the socket that we just looked at. So this is the socket that we were just looking at before. Now we know we have a mechanical break earlier in the chain at this point. And again, if I go into the socket and I probe one side, I'm getting about 0.4 volts on one side. And if I probe the other, I'm getting basically, 0.19 volts or so on the other side. So really not a big voltage differential at this point. We know that this socket overall is really not getting any power to it whatsoever. And we know this because there's a break in the series connection at the beginning of the strand at this bulb. So to show you why this particular socket is a little bit different and where my metal prong issue was, you can see here that this particular socket has sort of a notch out right there. It's a little bit different from the other sockets. And there's a piece of metal in there that you can kind of faintly see. That piece of metal was pushed back into that gap right there. So there's a little bit of a challenge with some of these connections at the beginning or end of the strand that you might want to be aware of. But that is basically the culprit of what happened with my strand of 50 bulbs that was out.